Welcome back to the channel. Last episode we talked about EV owners eventually getting paid to sell their energy sitting in their battery back to the grid, basically turning your car into a moonlighting power plant. We're moving past the plug-in and wait charging to bidirectional charging, where electricity flows in both ways. Grid to car, and plot twist, car back to grid. This video is all about how much each automaker is handling home energy services for their EVs. And yes, this is an EV only party. Gas and diesel vehicles weren't invited because they don't have a giant traction battery just sitting there ready to moonlight as a generator. During a power outage, your EV can quietly step in, power your house for 3 to 7 days, depending on the vehicle. Not every automaker is doing this the same way, so let's tour the home energy strategies of the biggest EV players in North America. Now, picture this. The power is on, and then it's off. Your fridge starts making noise you've never heard before. Some people have generators and they start firing up. Some people have home batteries. And now EV owners can basically build their own tiny power grid in their driveway when the utility ghosts them. Home and EV batteries can also play the stock market with electricity, soaking up power when it's cheap or free, and then selling it back when it's expensive, making the owner money. Don't worry, there are protections in place so your car doesn't sell off its last 10% right before your commute. Let's start with Ford, who made huge headlines with the F-150 Lightning as the first commercially available vehicle-to-home system. I helped Siemens as Ford's partner on that program, and honestly, watching the first real EV hit the residential market like that was a proud, we did a thing kind of moment. An F-150 Lightning with the Ford Intelligent Backup Power Bundle can power your house when the utility taps out, pushing 9.6 kilowatts your way. To get there, you need an 80 amp Charge Station Pro that's $1,300, a home integration system from Ford's partner Sunrun. That system brings a transfer switch, an inverter, and a small dark start battery for $3,900 total to kickstart everything during a blackout. Think of it as jumper cables for your entire house. The biggest battery Ford offered on the Lightning was 131 kilowatt hours. That's enough to run your home for over 4 days. All in, the hardware runs about $5,200 plus installation. Let's call it another $5,000 depending on how much your electrician has to fight with your walls and how far the electrical run is. With a fully charged extended range battery, the Lightning can comfortably power a typical home for as much as 10 days. Basically a very expensive, very quiet generator that also happens to drive around. Quick terminology note, though. A whole home backup generator uses a starter battery. Home batteries and EVs use what's called a dark start battery, the jumper cables of the operation, to get the circuits breathing again the instant the grid disappears. Next up is General Motors. They're running things on their Ultium platform and their newer GM Energy division. GM is making vehicle-to-home standard across everything. The Silverado, the Blazer, the Equinox, the Lyriq, the Escalade, the Sierra, you name it. If it's a GM EV, it's invited to the backup power party. To power your home, you'll need the GM Energy Power Shift Charger that can deliver up to 19.2 kilowatts. That can be paired with their enablement kit, which sounds like something out of a self-help book, but it's hardware. The Silverado EV can export 10.2 kilowatts from its enormous over 200 kilowatt hour battery, which is enough to keep the home running, any kind of home running, for over 6 days. That's basically enough juice to outlast most Wi-Fi outages caused by squirrels or any other thing that's going on the power lines. The power shift charger and the enablement kit run about $7,300 with installation similar to Ford's, which would be about maybe $5,000 or so. Now, the EV pioneer, Tesla. Surprisingly, Tesla has been pretty cautious of bidirectional charging until recently. They had the Powerwall, now on version 3, covering a lot of these cases for homeowners already, and it's a great product. The Powerwall 3 holds 14 kilowatt hours, so you can see why someone might want to eye the 123 kilowatt hours sitting in the Cybertruck and think, why am I buying a smaller battery when I already own a much bigger one that also has cup holders? Right now, the Cybertruck is the only Tesla with the official Powershare bidirectional capability, though the rest of the lineup is expected to catch up by, soon. If you already have a Powerwall installed, you don't even need the extra hardware to pull backup power from the Powertruck. It just slots right in. If you don't have a Powerwall, you need a Powershare gateway plus the universal wall connector. 2 things. The gateway delivers 9.6 kilowatts of continuous power and smoothly flips your home to backup mode during an outage. This bundle runs $2,000, and installation is likely cheaper too, since there's no separate wall inverter to hang. Here's the clever bit. Tesla uses the onboard charger to invert the main battery's 800 volts DC down to 200 volts AC for your house, instead of requiring you to install a separate inverter on the wall. It's classic Tesla. Tight vertical integration, fewer boxes on your wall, fewer things to go wrong. I suspect every automaker will eventually land here, inverting DC to AC on board the vehicle instead of outsourcing it to a wall-mounted middleman. Using 2 separate devices to invert a large voltage is the we'll fix it later move you expect when your supplier can't hit a price target. And Tesla just skipped that step. Keep an eye on Tesla moving the Model 3 and Y from 400 volts up to 800 volts, and likely bumping their auxiliary battery voltage from 16 volts to match the 48 volts the Cybertruck already has for the dark start capability. I'd guess they wait until their market share dips below before pushing that kind of refresh, because they're already sitting at 50.5% of the total market. Now, over to Nissan, Hyundai, and Kia, who are all leaning on the same supplier, so we can knock them out together. Pair a Wallbox Quasar 2 bidirectional charger and its power recovery unit with the 3-row Kia EV9, and you've got yourself a battery on wheels for your home. The Quasar 2 charges and discharges at 12 kilowatts, though it's not shipping quite yet. An EV9 with a 100 kilowatt hour battery could power a home for more than 3 days. 12 kilowatt hours in and out, that's the best rate on the market right now. But at $9,449, it's also the priciest ticket to the show. For comparison, Tesla's $2,000 and GM is $7,300. Wallbox will also need to ditch the clunky CCS1 adapter it's currently using in favor of the smaller NACS, or the Tesla connector, that's becoming the standard across North America. So what about the rest of the North American lineup? Rivian offers a wall charger and a mobile charger and has a partnership with WeaveGrid, but hasn't announced anything for home energy services on the R2, R1T, or the R1S yet. The silence is kind of deafening. Lucid absolutely has the tech ready in their Wonderbox charger, and I bet money on a home gateway announcement is down the line. The utility program that pays you back work a lot like the ones you might already know from your smart thermostat, from your Google Nest, let's say. Utilities figured out how to nudge your AC down between 6 p.m. and 9 p.m., tapping into what may be 4 kilowatts here and there. These new EV programs are a completely different beast entirely, controlling chargers pulling 10 to 20 kilowatts continuously and then pulling roughly 10 kilowatts back on command to the grid. Your thermostat was doing the electricity equivalent of asking nicely, and your EV can actually pay rent, so to speak. Texas programs are offering Cybertruck owners up to $4,500 a year, and it's not hard to see why. A couple thousand EV owners plugged in can let a utility skip building an entire gas plant that would have only run for 3 to 4 hours a day anyway. PG&E, CenterPoint Energy, Encore, 3 utilities already running residential energy programs for EVs. A quick reality check on how the U.S. grid is actually organized, though, that there's about 200 investor-owned utilities that serve about 70% of electrical ratepayers, of customers. 2,000 publicly owned utilities cover the other remaining half, 15%, and about 900 electric cooperatives cover the last 15%. Expect more of these players to roll out electric-friendly EV programs over time, because this is still early innings for very conservative companies. My guess for where all this lands, eventually everyone standardizes on 48-volt auxiliary batteries, 900-volt main batteries, using that low-voltage system to start the whole operation when the power drops out. That collapses the current 3-device setup, charger, inverter, gateway, down to just one, the gateway, sitting on your wall like a very calm bouncer, coordinating between the grid, the vehicle, and the house. I also think gateways eventually go vehicle agnostic. As long as the onboard charger and the gateway can talk to each other, the brand shouldn't matter. Which makes me a little skeptical of Wallbox's long-term game plan. They expect export DC voltage straight from the high voltage battery to the Quasar 2's own inverter and then flip it to AC right there in the unit. That locks them into a narrow club of vehicles that are built to export DC directly that way, whereas all the other cars are exporting AC. If exporting DC power is Betamax, then exporting AC is VHS. Betamax was arguably better than tape, but VHS won on marketing, ease of use, and scale. History has a type. So the bottom line, treating your EV like a home battery isn't a George Jetson fantasy anymore. It's a Tuesday. A complete vehicle home setup runs between $5,000 and $15,000 all in, and then it quietly pays you back every year for just doing what you were already doing, sitting in your driveway plugged in. So which automaker's home energy strategy do you think wins this thing? And to be honest, did the DC versus AC explanation actually click, or do you need me to draw it out on a separate video? Let me know in the comments below. Like the video, sign up for alerts, and subscribe to our channel.